Good afternoon, everyone. This is Bill Even, the CEO at the National Pork Board in Des Moines, Iowa. Sorry to be having you on a webinar here on a Sunday afternoon, but our worst case scenarios are starting to materialize. Every single person in the U.S. pork industry has been working diligently for weeks to try to avoid the situation we're facing today. Unfortunately, we're running out of options here in the nation. And the purpose for this call is to provide just some practical, very practical information around how to manage emergency depopulation and disposal of parts of the nation's hog herd due to the fact that our packing industry is experiencing slowdowns and stoppages due to COVID-19. So there's kind of three main points that the industry has been working on for the past 3 weeks. And talking with the administration, as well as talking with state veterinarians and other people across the nation. Number one is the real sense that we truly need to understand how we're going to balance public health while operating the critical food system. The situation we're in now is an example of that. It is what it is here right today, but rest assured those conversations are ongoing even over this weekend. Number two, that's the purpose of this call today, is dealing with the on-farm livestock emergency in an immediate fashion. The USDA is stepping in and helping out, and we've got some folks from the USDA on the call here today to give us some information. But be very candid with you folks, this is going to be a tough slog. There are a number of states and state pork associations and state vets and producers that have looked for and are attempting a few options to get ready for the coming weeks. But we're really looking for that national sort of coordinated effort. And so thank you for the USDA for their assistance on this. I do want to let you know as well that the National Pork Board here in Des Moines has had an incident command center established to serve as a focal point to feed information in and out in conjunction with our partners at the National Pork Producers Council. Number three, and this is where the National Pork Producers Council has been working on your behalf. They're working with the USDA and the federal government to find funding to cover some of the marginal costs for the depopulation and disposal that the nation is facing. And so with that, I'll go to the next slide. And as always, we're very alert to antitrust issues. That's what this slide is about. And a reminder that the views expressed by our invited guests are theirs and not those of the National Pork Board, which does not advocate or endorse any particular production, marketing, or business direction. If you go to the next slide, we'll talk a little bit why we've got this webinar out here. We have got a vast amount of information at pork.org where you can go and get information. And we've got this assembled from a lot of public sources, as well as veterinary industry and the USDA. Next slide. This slide you're going to see again at the end as we close. If you got a pen and paper handy, be sure to write these things down. It's the pork.org website. It's the phone number to the Pork Board Service Center, as well as a place where you can send emails. And so if you've got questions about this, we are here to serve as a conduit for you and back in with the USDA, our partners at the National Pork Producers Council, as well as the American Association of Swine Veterinarians. Next slide. So the speakers today, myself, we're going to hear a few remarks from Mr. Kevin Norton. He is the Associate Chief at the National Resources Conservation Service. Kevin is going to be joining us today to talk a little bit about the disposal side of the equation and where the NRCS is stepping up to provide some assistance. There are some guidelines that we have to follow here, and Kevin's going to touch on that. Next, we'll have Dr. Dave Pyburn, our veterinarian here at the National Pork Board. Dave is going to give a few references and resources that you have at your availability. Then we're going to move into the heart of the presentation with Mark Rice. He's the extension specialist out of North Carolina State. Mark is going to walk us through emergency euthanasia. And then we are going to close with Lori Miller, the environmental engineer at USDA Animal Plant APHIS. And so with that, I think we might as well get started on what is a topic that makes us, frankly, all sick to our stomach, but we're going to have to work through this as a team. So with that, I'll turn it over to Kevin Norton with the NRCS to make some remarks. Next slide.
Thank you very much, Bill, for letting me join y'all during this very difficult time. A couple of weeks ago, we were informed of the situation with the closing of the plant at Sioux Falls, and we've been working to engage our environmental quality incentive program to provide a level of assistance to growers that are going to have to euthanize and dispose of the carcasses. Our work within the Natural Resources Conservation Service and our program authorities do limit us to working with the carcasses themselves, not any of the work that occurs prior to the euthanasia. We are going to make the program available to eligible producers with 4 options that the producers will be able to select depending upon their situation. Of course, burial, forced area incineration, carrying to a disposal for landfill or a renderer, and then what we're calling is just any carcass disposal other than burial, incineration, landfill, or rendering, which essentially is outside composting of the carcasses. So we're going to make that available in the states. As I visited with the folks this morning, we really need the state associations to reach out to your state conservationists. We can't get real specific about the program offerings within each state because many state governments have some regulatory conditions or requirements around the methods of disposal. We're aware of a state that does not allow any burial or forced area incineration, so there's a limited options there. But our state conservationists are aware of that. They're working with the state agencies and APHIS, and will provide the options available for the producer to select from. So we're asking, the state associations to reach out. Our state conservationists are available. They're aware, and in many cases have already talked to individuals, not only within the state producers associations, but also within state government, and are preparing to deliver this. For the producers, we ask that you point them, if they're needing to do this activity before they initiate the euthanasia, have them get a call to their local NRCS service center, the field office that services their operation. In the states that are engaged here, many of you have already worked with the Farm Service Agency, or even probably other contracts on your cropland, other related activities, and know about our agency, know about the service center there locally. They need to reach out. We need them to have an application and a waiver to commence the practice before they begin the process of euthanizing and burying the animals. We have some very specific things we'd like to discuss with the individuals about the number, the method of disposal, not euthanasia, but disposal. And also, we have to make sure that they meet eligibility requirements, and those are all very much specific to the individual. So we ask 2 things. One is that the communication that you need relative to the state is coordinated through the state conservationist, and then that as you're visiting with producers, if they're going to euthanize animals, to be sure that they reach out to their local office and file an application for the Environmental Quality Incentives Program. We're limiting the total payment to $25,000 per contract item. The payment rates vary by animal unit based on the disposal method, and an animal unit essentially equals 1,000 pounds of animal. So, it could be three pigs at 333 pounds, or whatever division it takes to get to 1,000 pounds of an animal, which will equal the animal unit. With that, those are the key things. We are putting together a general fact sheet. We're going to provide it to Bill and the team, and they'll put it up on their website. Hopefully we can have that tomorrow. If not, it'll be very early in the week, and so that y'all have some general guidelines, contact information for folks to get in touch with our agency. With that, I'll pass it back to you.
Thanks very much, Kevin. We really appreciate you joining the call today. And if you advance the slide, we will turn it over to Dr. Dave Pyburn, the Chief Veterinarian at the Pork Checkoff. Dave?
Thank you, Bill. Good afternoon, everyone. I don't need to tell you, but due to the COVID-19 pandemic, agriculture as a whole, and especially our pig farmers, are facing animal care and marketing challenges the likes of which we have never seen before. Due to packing plant shutdowns and slowdowns and animal welfare concerns, our farmers are faced with having to euthanize and depopulate pigs that have grown to be way too large. This is a last resort option that many are facing right now or could face in the very near future. This webinar today and the materials provided at the web link in your webinar invite will help you with some of the decisions you are now facing. What we're looking at here is the euthanasia options as they exist from the American Veterinary Medical Association. This is the association of U.S. veterinarians. They have guidance documents on depopulation and on euthanasia, and that's where this information was pulled from. USDA looks to this organization for guidance on appropriate methods of euthanasia. When looking at these options, you need to choose your method, make your plan, and implement euthanasia, but only do that in concert with your herd veterinarian. You will see at that link that I previously talked about, there's a document in there called Depopulation Method Options. That document walks you through this decision process, this planning process with your veterinarian, and also helps you to document how you got to the method that you arrived upon if you have to do this on your farm. When we're looking at these options, we need to balance animal welfare and human safety considerations. We also need to adhere with all applicable state and federal animal cruelty laws. Check with the office of your state veterinarian ahead of time for such regulations. The preferred methods in the left-hand column, these are the highest priority methods, and they should be used when circumstances allow. And you can see that our topic today, which is carbon dioxide euthanasia, is in that preferred method column. Those in the middle column, permitted in constrained circumstances, are to be used when circumstances keep us from being able to reasonably implement a preferred method from the left-hand column. Some of those potential constraints, but not a complete list of them, but some of them as listed by the American Veterinary Medical Association are human safety concerns, depopulation efficiency, deployable resources available, and also equipment available to perform the euthanasia. Today, as I said, we will concentrate on how to set up and perform carbon dioxide mass depopulation. If you would, please advance the slide, Chuck. And so here is a material, a national listing of carbon dioxide providers. Not a complete list. We will add to this list as we discover others that are either local or national. And this too is also available at the web link that you got in the webinar invite so you could be on here today. And there are many other COVID-19 production management materials at that same web link. So I encourage you to take a look at that web link, browse through there after this webinar today. And I would also encourage you, as you just heard from Kevin with NRCS, there will be additional materials that get posted there as we move forward. So what you see today will change in the coming days. Also on our website at pork.org/COVID-19, you will be able to find this webinar as recorded. So you don't have to be taking pictures or trying to rush to scribble down this information that we're giving you today. Thank you, and I'll turn it back to Bill.
Thanks very much, Dr. Pyburn. Next, we're going to switch to Mark Rice with North Carolina State University, who's going to walk us through using carbon dioxide options for euthanizing swine. So Mark, if you want to unmute yourself, you're ready to go. Mark, can you hear us? All right, looks like Mark might be having a little problem with his phone. So Chuck, I'm going to have you move forward, and we're going to have Lori Miller present on her slides with disposal while we work with Mark on his audio. So Lori?
Yes, thank you so much. I'm sorry to be talking to everyone under these tragic circumstances, but I hope that we have some information that could be helpful. So I'd like to talk about the swine disposal considerations during this incident. Next slide. And I'm going to talk about the pros and cons of the various off-site and on-site disposal methods, considerations, as well as some other ancillary activities like temporary storage and transport of carcasses. Next slide, please. So starting with incineration. Incineration in this context refers to packaging carcasses into containers. And you may notice at the bottom there are some photographs. This was an exercise conducted in Indiana a few years back using chickens. And
okay.
It could be...
Okay, I'm back, sorry.
Do you want me to continue, or shall we turn it back over to Mark?
No, why don't you go ahead and continue, Lori? Sorry.
Okay. No problem. So this method could also be used for pigs. You need to check with the incinerator facility to determine what size containers they require. The ones shown in these photographs are approximately a cubic yard. And so the process involves packaging the materials, transporting it to the waste to energy facility, and then loading it into the hopper where the materials are picked up by this gigantic grapple that drops them onto the hearth. And so this is energy efficient in that the heat energy is captured and used to generate electricity. It does require off-site transport. There aren't a lot of these facilities in the U.S., and so it may require quite a bit of transport to get there. And, you know, it's environmentally friendly, very efficient, designed to handle waste materials, but depending on the distance, somewhat expensive. Relatively low risk when you're talking about releasing things to the environment because these are permitted facilities that have emission controls. Next slide, please. Okay, so landfill is another off-site method that involves hauling the materials to the landfill, and it is quick. Just the transport is what's needed. Landfills are located in pretty much every community around the U.S. But there are some limitations as to how much and what type of waste material landfills can accept. And so landfills are typically constructed with a liner and either a plastic membrane or a clay layer. There's a leachate collection system that collects the liquids that come from the waste materials. And then as the materials decompose, it decomposes by anaerobic decomposition, which generates methane. And often that methane is captured as as a natural gas type fuel. The landfill may have limited capacity. They're designed to handle waste from municipalities or specific communities, and so getting a huge influx of other materials like carcasses could take up space that they need for their community, and it could also lead to operational problems like slope stability problems and change the nature of their leachate, which they're permitted to generate and dispose of, and if it changes significantly, that could violate their permit conditions. So, it could be cheap and easy if the landfill is able to accept the material. It could be quick if you have one nearby, relatively inexpensive, and because landfills are designed to protect the environment, there's low risk from using this method. Okay, next slide, please. Rendering, which I'm sure most of you are familiar with, involves hauling to a rendering plant where the carcasses are ground and then fed into a cooker, which separates the material into 60% is a steam or water portion, 20% is fat or tallow, which can be used as biodiesel or other useful products, and the remaining approximately 20% is a meat or bone meal, which is typically used for pet foods, animal feeds, fertilizer, and other useful byproducts. It is specifically designed to manage animal carcasses, so it's highly efficient and sustainable. It reduces the volume of material. It can have relatively high throughput, but there may be limited capacity. So we don't have a lot of rendering capacity in the US, and with this huge influx, it could definitely tax the capacity that we do have available. Of course, the carcasses do have to be transported to the rendering plant. If you have one nearby, it could be relatively quick. Average cost, and the only reason it's potential risk was because this slide was developed related to animal disease outbreaks. But in this case, there is no risk of spreading infectious diseases. The temperature in the rendering process gets hot enough to inactivate most anything. Next slide, please. So let's shift over to the on-site disposal options. Burning has traditionally been used around the world as one of the go-to options for carcass disposal, but it is not environmentally protective. It emits significant particulate matter, which during the 2001 UK FMD response, they calculated that every pig that was burned generated on the order of 3 pounds of particulate matter to the atmosphere, and particulates are responsible for asthma and other health effects. Also, the throughput is relatively low, and so the photographs at the bottom there, the one on the far left shows an open pyre, such as those they were using in the UK, which are expensive to construct and maintain, and will emit vast quantities of smoke, and so are not recommended. We generally don't even consider them for use in the US when we're thinking about animal disease outbreak response. Some more controlled methods are the two photographs in the center, which are air curtain incinerators. The one on the center left is a trench burner, and the one on the center right is a box unit. And in essence, the carcasses are ignited in combination with some other fuel like wood, and diesel or natural gas can be used to keep that flame going, and then a curtain of air is blown across the surface of the flame to keep the fire going and to minimize emissions. But you can see on the center right photograph that emissions are not eliminated. And what we found during 2015 high-path avian influenza response was that we were only able to process about 5 tons per day of carcasses in these units. So the throughput is limited. Another option on the far right are mobile incinerators. And again, they are limited, but the ones that are more contained, and there's several different manufacturers around, it's more of a gasifier system, can have very low emissions. So, this would not require transporting carcasses anywhere, and it would drastically reduce the volume of the carcasses to about 95%. All you have left is ash. But the throughput is not that high. There are some air emission risks, and it may be difficult to permit. You also have to get the units to the site, and availability could be an issue. Okay. They're, average in terms of speed to get in place, relatively expensive, and average in terms of pathogen risks. But again, we're not really focusing on that here. Next slide, please. Burial is another option that people traditionally think of for disposing of carcasses. It can be performed on farm. It's easy to implement, and it's out of sight, problem solved. However, there's a lot going on below ground in a burial pit. So typically the pits are 12 feet deep or so, and there are multiple layers of animals placed in the bottom of the pit. It's covered over with 3 to 6 feet of soil and left to decompose. Well, what we have found over time is that at 12 feet below the ground surface, there are not a lot of microorganisms working to decompose carcasses. And so quite often we find that places that have been used for burial, decades in the past, are sometimes developed for housing or other purposes. And when they dig into the piles, they find that the carcasses are relatively intact. Also, the carcasses, although they appear intact, so the tissue hasn't broken down to a great extent, they do release a good bit of moisture. And so that liquid or leachate flows out of the carcasses into the soil, and depending on how far the bottom of the pit is to the water table, it can reach drinking water and pose risks to humans. And the primary risk would be nitrogen, and nitrates in particular pose a risk to infants. It could be fatal to infants at high levels. The levels of nitrates measured below these burial pits, or at least nitrogen as ammonium, ranges in the 2,000 parts per million range, and the drinking water standard in the U.S. for nitrate is 10 parts per million, so 2 orders of magnitude larger. So it's unknown what effect that burial site might have on drinking water wells in the vicinity. It depends on the distances, the flow rates, and the soil types. And that's where your environmental regulatory agency can be very helpful, as well as the Natural Resource Conservation Service. They both have lots of information about soil types and suitability for carcass burial. Sometimes folks in the center picture here, they try to use tarps or something else to prevent the leachate from migrating out of the burial pits. But as you can see, these tarps aren't really continuous. I wouldn't build a swimming pool like this and expect it to hold water. And so similarly, it's not likely to contain the leachate. So that means it has a potential public health risk. It doesn't provide any useful benefits. It can limit your future land use. And if you contaminate the water supply, then you might have to clean it up, which is an incredibly expensive proposition. It can be quick to implement, cheap, but there's potential high risk for environmental liability. It's very site specific. Okay, next slide, please. Composting is another option, which involves placing approximately a 1-foot layer of wood chips or other carbon material on the ground, placing a layer of carcasses on top, and then covering it with another 1 foot layer or so of additional carbon material. The carcasses that are shown in these photographs here are poultry, which are relatively small, and so they break down quickly. It only takes about a month for even turkeys to break down in composting. However, for whole swine, first the abdomens have to be lanced for each animal, and then once they're placed in the compost piles, it can take up to a year for them to fully decompose in the compost process. I'll talk a little later about grinding, which we've looked at to expedite that process, and we find that grinding takes it from up to a year down to less than a month. So again, this animals have to be, the abdomens have to be lanced if they're not ground. It could take up to a year for it to fully decompose, and so the land area will be occupied for that 1 year period. It is safe. It's very little impact to the environment. In studies, we have seen soil chemistry changes, nutrients, to about 4 feet below the ground surface. And so as long as the piles are far enough from the water table or other susceptible features, then it is safe. It does produce a useful byproduct, a soil conditioner, and in some cases, if the nitrogen content is high enough, like it was for our outbreak responses, then it's also a fertilizer. But it does have to be land applied in compliance with the agronomic rates and your nutrient management plan. And although it is a simple process, it's not easy. It's both an art and a science. And so we have found that unless a subject matter expert is involved with ensuring that the piles are constructed properly, they may not heat up well, they may have odors, and you may have to call in an expert after the fact. And sometimes the piles have had to be rebuilt, which is, it just adds additional cost and time. Okay, next slide, please. The last disposal option I want to talk about is above ground burial. This was developed by colleagues at Virginia Tech and the Virginia Department of Environmental Quality, who were trying to come up with a safer alternative to deep burial. And so it is somewhat of a hybrid between composting and burial. And so in essence, it's a 2 foot deep trench, a 1 foot thick layer of carbon, such as wood chips, in the bottom of the trench, a layer of carcasses. And if you're doing whole carcasses, again, each of the animals has to have their abdomen lanced. And then that layer of carcasses is covered over with the soil that was excavated from the trench, and then it's planted with a seasonally appropriate grass. We have been studying this extensively. We have found, similar to composting, that there are changes to soil chemistry, at least in Oklahoma, where our largest study is, to about 3 feet below the bottom of the trench. So that would be about 5 feet below the ground surface, at which time the soil chemistry returns to the background levels. And we have found that to be holding over time. At the end of the process, so for whole animals that have had their abdomens lanced, it takes about a year for them to break down. At the end of that year's time, you may have a bit of a mound, which can be graded. There is no material that has to be managed afterwards. And we have found that the plants and the soil are very nutrient rich. So we found high levels of protein and nitrogen in the plants that were growing over our plots in Oklahoma. And just as an aside, that study was looking at 100 sows, so fairly large scale. It's pretty straightforward. You don't necessarily need an expert to help construct these plots. You do need some carbon source and some space. It takes about a fifth of the carbon and about a fifth of the space that composting would take. I don't know whether this would be covered by NRCS's EQIP program. Maybe that's a question for the question and answer period. And we have not had problems with scavengers unearthing the carcasses. All of our tests have included trail cams watching the sites, and we've seen black bears, foxes, possums, deer, all sorts of creatures walking across the plots, but none of them digging into or disturbing the plots. So this is relatively, average time to implement, inexpensive, and average risk. It is, however, still undergoing field trials, particularly related to disease outbreaks. For this application, I think it could be a really useful tool in the toolbox. Next slide, please. One important factor when considering disposal is that the rate of depopulation needs to be the same as the rate of disposal. If you're putting the animals down faster than you can dispose of them, then you have to have some method for storing temporarily those carcasses while they're awaiting disposal. It can be a leachate and odor problem, and some possible solutions to that are covering the piles with carbon source or tarps, making sure that any temporary storage is not going to be near a waterway where leachate might impact it, and it needs to be protected from scavengers. So that could be a challenge, and the easiest way to manage it is to not depopulate faster than you can dispose. Next slide, please. Just touching briefly on transport. It's going to be a challenge in this situation. So depending on where the depopulation occurs and where the disposal will be, trucks will have to be arranged to keep that process moving. Next slide, please. We talked about grinders. There are a couple different kinds. We have done some experiments with horizontal grinders. Next slide. And so the horizontal grinders are similar to what's used in forestry applications. We've tested 3 different sizes, 515, 750, and 1100 horsepower units. All of them were able to process 60,000 pounds of carcasses, and this was pig carcasses per hour. Our studies were both in North Carolina and Minnesota, and we did find that the 515 horsepower unit did not require a special transportation permit like the larger units needed. Next slide, please. I'm sorry, could you go back to the previous slide? Just to look at this photo a little more closely, this was during our North Carolina work, and at the far left, you'll see the material coming off the belt. And so when it settled, it was pretty much sawdust size. You couldn't identify any tissue or particular carcass parts. We found that using an excavator with a clamshell type apparatus, as you can see there, some people call it a thumb, to pick up the carcasses and place them on the belt, and then have a bucket loader like on the right to place a scoop of carbon worked best. And we did try running the carcasses straight through without any carbon, and that kind of gummed up the work. So we use approximately a 1-to-1 ratio. grinding drastically reduces the volume of the material. Unfortunately, I don't have any statistics on that at my fingertips for this conversation, but significant volume reduction. Next slide, please. Some other things that we found was that alternating scoops of tissue and carbon worked best. In the case where you're not using that clamshell device and maybe you're using loaders on each side, one loader for the carcasses, one loader for the carbon, you can keep odors and flies down by placing some carbon over the top of the carcasses. And it helped with the mixing as well. I already mentioned that composting whole pigs can take up to a year if you lance the abdomens. If you grind the pigs, you don't have to lance the abdomens, and it takes less than a month to compost. We also tested above ground burial with whole pigs, and that was up to a year, less than 6 months if they were ground. Next slide, please. So in order to figure out what to do with this crisis facing us, there's some information that will have to be collected. So first is going to be the number and average weight of pigs that need to be disposed of per day per location. And so if folks are depopulating on site or at a centralized location, like if you know, a packing plant can be repurposed for depopulation only, whichever location they're originating from, you have to figure out what is the rate that you're generating carcasses, because you want to keep up with that so you don't have that storage problem. You want to have approval from the environmental agency in that state for the destinations. You know, you want to have your trucking and storage options lined up ahead of time and to know those capacities. And you'll want to know what is the capacity that the disposal facilities can accept. So their daily rates and, quite likely the amount of material, the rate of depopulation, I would guess, is likely to exceed the availability of rendering. It may exceed landfill, and so other options may also be needed, like on-farm disposal, or potentially, if there was funding, which we currently don't have, but if it becomes available, perhaps a centralized location where grinders could be set up and disposal could be performed. And so if that was the case, then considerations like the availability of fairgrounds, opened or closed landfills, or other sites where the centralized locations operations could be set up. In any event, wherever the disposal takes place, you have to consider the availability of disposal staff. That will also be a limiting factor, as well as the availability of grinders, if you're going that route, carbon material, as well as equipment with operators. Next slide, please. So, where you're taking the material is important. If you're going to a rendering plant, that would be ideal. It's a great option. However, we have limited capacity. Landfill is another great option, economical, but it may be limited as well. Don't know whether it will be easier for landfills to take material if it's ground first, because that would reduce the volume and help with the slope stability and the leachate concerns. If a centralized location could be funded, we would need permission for the property. We would have to assemble all the assets there and have an entire system of operations. And if the disposal will take place on farm, it minimizes transport if depopulation is happening on farm. However, many farms have limited space, and there may be shallow water tables causing environmental limitations, and it could also be labor intensive. Next slide, please. I just want to briefly tell you about a tool that APHIS has available. Next slide. At the URL at the top of the slide, we have a carcass management dashboard. And if you went to step 1, next slide, please, and click there, you would see this other link to a calculator. Next slide. And the calculator allows you to input information about your location, the number of animals, size of animals, and it reports back the relative costs of the various options based on distances, amount of carbon you would need, how much leachate would be generated, how much space you would need, how long does it take, and those types of facts. It also shows time and cost, time being the blue bars, green being cost, in a graphical image for quick decision making. Next slide, please. If you don't know off the top of your head how far it is to your nearest landfill, incinerator, or rendering plant, you can either use the default values, which are shown here, or you can go back to the calculator, step 1B, next slide. Click on the routing map, next slide, and type in your the address where the carcasses are located. And that will bring up a map which has L for landfill, R for rendering plants, and I for incinerators. Note on this slide at the bottom that there's, you can see a bit of a sort of a spreadsheet showing up there. For each of the facilities shown on the view, it lists the contact name and phone number, the company name, their latitude, longitude, did I say phone number? And so it's important to identify the nearest sites, contact them to determine if they'll accept the material and under what conditions. Next slide. This is just a closer view of a premises. You can measure the distance by using the measuring tool. You drop a pin on your premises, you drop a pin on the nearest disposal facility, landfill in this case, and it tells you how many miles as the crow flies. And since these are relative costs, it's appropriate that they're all as the crow flies. Next slide. And then you go back to the spreadsheet, you enter in those specific bits of data. Next slide, please. And it generates a site-specific report. I'm happy to walk folks through this. Next slide, please. And that's the graphical image. And so we had run, the one we ran and showed here was for 6,800 swine weighing 300 pounds each. Above ground burial came out to be the cheapest, fastest, and air curtain incineration was the slowest and most expensive. Next slide, please. There are lots of other resources on this website, including training modules, lots of articles and reports from research projects we've done over the years, as well as a number of tools and resources, such as a composting protocols, and even some that have been translated into Spanish. Next slide, please. We've included a list of composting subject matter experts that are located in the Midwest, and these are folks that are on our USDA roster. There may be others that we're not aware of, but it's a starting point. The ones with asterisks are not located in the Midwest, but they're the top tier of national experts, and they can likely provide virtual support and guidance. Next slide, please. In terms of locating carbon sources, that's going to be a very local situation depending on the time of year, weather. The Minnesota Board of Animal Health does have a website where they have listed carbon sources with contact information. It's a really incredible resource, and so I've included that here. Next slide, please. Here are a list of some grinder manufacturers, and contact information. Next slide, please. And then our contact information as well. Thank you.
Thank you very much, Lori, for running through that information. And as Chuck, if you want to go back and get set up with the slides for Mark, we'll switch to him next. And while we're doing that, one of the things I wanted to mention and remind everybody, Dr. Pyburn said, but this webinar is being recorded. These slides will be sent to every attendee on here because we have your email. And we are also going to post the recording and all these slides on the pork.org website. So I just want to remind you folks of that. And Mark, you want to check your phone? Can we hear you okay?
Can you hear me now?
Yes, sir.
Am I coming through?
Hear you loud and clear,
All
Mark.
right.
We'll let you.
Good deal. All right, thank you. Well, good afternoon. Sorry to have to be talking to you about this topic at this time, but just wanted to share a little bit about the experience we had with this was a project that was funded through USDA to look at carbon dioxide as an option for mass depopulation of swine, and just share some lessons learned. I know we're not going to be able to get to the point where you could go home and build a system today, but just give you some things to think about and some resources to go. Got some papers and links to some papers that you could look at, and some instructions on how to put a system together. But I would encourage you to, as soon as, if you're serious about using CO2, talk to your supplier of CO2 and see what's available and how, what form it can come in, what type of containers. Can you get truckload, a bobtail truck, or large cylinders? You know, because that's going to impact the system to some extent, how you set up a system. So next slide, please. Using CO2 for euthanizing animals, the size and scale matters a great deal. To meet the AVMA requirements, you have to replace the chamber volume within a 5-minute period. So whatever type chamber you're going to use to euthanize the animals with the CO2, you've got to be able to supply that amount of CO2 over a 5-minute period, or 20 to 30% of the chamber volume each minute over that 5-minute period. CO2 is generally delivered as a pressurized liquid in high pressure tanks or trucks. If you can use it at low flow rates, if you've got a small chamber, you can just draw off the headspace gas, and that's pretty straightforward. Just pull that gas off directly into your chamber. But most of the time, for the size chambers we're going to be using, trailers, dump trucks, whatever you're probably going to have to be using high pressure liquid. And when you do that, when you release that high pressure liquid, approximately only about half of that gas is going to come off as gas. The other 46% is going to form dry ice, or a solid form of carbon dioxide. It's still available, and it will eventually sublimate or melt, but it's not going to be readily available at that time. Next slide, please. You're going to be looking at about 1.5 to 2.5 pounds of CO2 per pig. So for 2,400 head finished animals, you're going to need about 3,600 to 6,000 pounds of CO2, depending on whether you can fully utilize the part of the dry ice that is formed. The picture on the left you see there, we were just dumping liquid CO2 from a truck into that drum and then pulling the gas off that drum. And in this instance, and I'll talk more about it later, running it through a tube in the ground to warm that gas back up before introducing it into the chamber. The picture on the right is the dry ice that was formed after about 20 minutes of running that system. And so, that cloud you see coming off that is the dry ice sublimating. So that gas, if you can contain that dry ice in a container, you can still recover that CO2 and utilize that in the process. Next slide, please. Keep in mind that 1 pound of liquid CO2 will yield approximately 8.5 cubic feet of CO2 gas. So that's where you're going to, depending on the chamber size that you're going to use, that will determine how much CO2 you're going to have to deliver to that chamber over that 5-minute period. And you're looking at $1 or more per pig for the CO2 cost. But here again, check with the supplier, make sure you can get what you need and see how they can deliver that to you on a regular, timely basis. Next slide, please. The first system is probably the one that I think probably has more application for most farmers, producers. Using a small dump trailer where you can load the animals directly from the barns into your trailer or chamber, tarp it, and then introduce the CO2 into that chamber over that 5-minute period. We generally would recommend a dwell time. So you introduce the CO2 over 5 minutes, let it sit there for 10 minutes, and by that time most of the animals would be euthanized, and then you'd take that to your disposal site. And as has been mentioned by some of the previous speakers, you definitely, in your planning process, you want to match your euthanasia process with your ultimate disposal process, and so that you're not putting down a bunch of animals and nothing to do with them. So have that all figured out ahead of time. In the picture in the lower right, you see the expanded metal top on the trailer. That was primarily to keep the animals' heads low and in the gas chamber. Also to support a tarp. So when before the gas is introduced, you pull a tarp over the top of the trailer and seal the tailgate, and then start introducing your gas. Next slide, please. This is just a schematic of what that system would look like. At the top, the high pressure cylinder, that could be a 100-pound cylinder. It could be a 1,000-pound micro bulk tank, or it could even be a full-scale 7,000-pound bobtail truck if that's available. But the principle here is you would flow that through just a regular standard regulator. You'd flow that gas at a low rate, low enough to keep from freezing up the regulator, that you'd let that bleed off into a intermediate low pressure tank. In our situations, and I'll show you a picture, we just used a used propane tank as an intermediate tank. It does need to be pressure rated, but it's at a 20 to 40 psi rating rather than the high 3,000-pound cylinder pressure. And then just a simple ball valve and an orifice plate to regulate the flow to make sure we meet that 5-minute application period, and then flow that into the chamber. Next slide, please. This system is suitable for small trucks and trailers. Kind of the flow rates has to be from the high pressure tank, has to be low enough to avoid freezing up the regulator, and that's fairly easy to you can see that happening and slows you'll start seeing frost forming on the valve and the regulator, so you can slow that flow rate down and then that low pressure tank gives that gas a chance to heat back up or warm up to near ambient temperatures. The orifice plate is sized to control the flow into the chamber to meet that 5-minute volume requirement. And then if you need to speed up that process, that refilling, because it'll take about probably 30 minutes with that system. We were using a 250-gallon propane tank, and it took about 30 minutes to recharge that. But you can put multiple cylinders with multiple regulators feeding into that to decrease the time it takes between batches. Next slide, please. So this is what it looked like in reality. The high pressure cylinder in the front of that picture to the right, a used propane tank in the middle, just a standard regulator coming off the high pressure cylinder with pressure regulator set at 30 psi, and so it'll fill the propane tank up to the 30 psi that we specified to match our chamber. And then that orifice plate picture on the two pictures on the right is just a piece of metal that was about a 1/4 inch hole drilled in it, but that would need to be sized to your chamber and your pressure in your tank. And like I say, I will give you a source of information on how to size all of that. So you just open the valve. It'll bleed that pressure off the intermediate tank into your chamber over the 5-minute period, allow you 10-minute dwell time, and you're good to go. Take that trailer to the disposal site, start on the next batch. Next picture. Next slide, please. This is just showing the results of that. The green line that starts up on the upper left-hand side and drops off is simply the pressure in that intermediate tank. So we started out about 30 psi. Over that 5-minute period, it drops down to atmospheric pressure. The blue line is the CO2 concentration in the chamber, the trailer that we were using. So you can see it started out low and then finished up about 60% of the volume of the trailer. So it worked really well, meeting our objectives. Next slide, please. So here's a reference for that, an article that was written for the Journal of Swine Health and Production. It is available online, and it goes through that whole process of designing, sizing and determining the pressures that you need in your intermediate tank. And so you should be able to. I've had several folks that have built units for routine mortality, euthanasia, but that have used those instructions. But if you need some assistance, I'll be glad to try and answer questions on that as well. Next slide, please. So you may need to go, depending on your time frame, you may want to go with a larger scale system, and it will work on. We've looked at grain bed trucks, roll-off dumpsters, dump trucks, anything that is airtight or that can be made airtight. So it's just mainly the lower part. CO2 is heavier than air, so you have to make sure there's no leaks in the floor of the trailer. The bottom seams, that you just cover those with duct tape, expanding foam, whatever you've got available to seal up the tailgates and any of the sideboards on the trailer to contain the gas. Like I say, you would generally want to tarp those, but leave a flap for a purge valve, so as the CO2's filling from the bottom, you discharge the CO2 at the bottom of the trailer, and then it'll displace the air that's in the trailer out through the tarp. Next slide, please. Just other examples of trucks tailgates were modified to facilitate the loading of the animals from the existing loading chutes, and then you can also then allow the carcasses to be dumped out if you're going to be if that works best for you. Next slide. Also constructed some temporary corrals, penning, to set that up. Here again, the biggest challenge is to make sure you've got that seam at the bottom, at the ground. That would either need to be sealed, set in a few inches into the soil to create a good seal, or we used just some foam sealer or foam gasket material on the bottom edges of that sheetrock or plywood to form that seal. Then you can run the animals in and administer the CO2. Next slide, please. We also looked at just a pit, and so there may be an option if burial is a method of disposal. You may be able to utilize that pit for both for euthanizing the animals and then completing the disposal process. At the upper end, you can see in the cover there's a flap cut. That's that purge valve. It's just a rectangle box flap in the tarp to allow the air to escape as the CO2 is introduced into the pit. Next slide, please. This is what we're trying to avoid with these systems. If you just dump go directly from the truck with high pressure liquid into a chamber, you're going to get a cold cloud of CO2 gas introduced. It's going to be terrifying to the pigs. It's loud, it's cold, and so this is what we're trying to avoid with these systems. And so this is what you don't want to see. Next slide, please. So one way of heating that gas coming off the trucks at that liquid is to use an earth tube, a heat exchange tube. Next slide, please. If you dig down, depending on where you are, in Iowa, it's probably going to be 5, 6, 7 feet down. But at some point, you get the soil is at pretty much constant temperature year round. Here in North Carolina, it's about 4 to 5 feet. So you can dig a trench, and we just used a corrugated pipe, black plastic pipe, drain pipe, buried that in the ground, and then use that, ran the cold CO2 gas through that to warm it up before being introduced into the euthanasia chamber. Next slide, please. So this is just our barrel again, coming off the truck, going through the barrel to capture the dry ice, because if you don't want to put that in your earth tube, it'll clog it up. And so then the gas comes out of the top of the barrel into the earth tube. Dry ice is captured in the barrel. And then next slide, please. So this is what what it looked like after about 20 minutes. The barrel was about half full of dry ice, and but then we were also at the same time we were getting about half of the CO2 gas going to our chamber. Next slide, please. So this just shows the effectiveness of the earth tube. The green line at the bottom is the temperature of the air going, or the CO2 going into the earth tube. The purple line, second line down, is the outlet going into the chambers. So when it was running, we had minus 80 degree Fahrenheit CO2 going into the earth tube, and about 50 degree Fahrenheit air coming out of the earth tube. So it's pretty effective at raising that temperature. To be humane, you don't want to be introducing that cold CO2 into the chambers. Next slide, please. So the earth tube works. It will successfully raise the temperature of the CO2 gas. You do need something ahead of that earth tube to capture the dry ice that forms. One option would be to use a a bag of some sort, an ag bag, silage storage bag, haylage bag material works really well. And then, or you can supply some supplemental heat to your dry ice collection system to sublimate that or melt that dry ice, and then it's readily available to use in the chamber, and save on total use of CO2. Next slide, please. So this is just an example of using an ag bag. This is a silage storage bag. It's low pressure at this point. You're less than a PSI pressure. Just used a 2x4 chip clip on the end of the bag to seal the end of the bag, and then pull the CO2 off the left-hand end of that bag into our chamber. Next slide. This is an example of a low-cost system to sublimate the dry ice that's formed, and also at the same time heat the CO2 gas instead of having to use an earth tube heat exchanger. You could use here we're just using kerosene torpedo heaters to heat our the chamber and the vessel for the CO2 collection, and it was about $2,500 for the heaters and the materials to assemble this. This looks a whole lot fancier than it needed to be, but this was we knew it was going to be used for demonstrations, and my technician wanted it to look good. So I successfully built one in about 3 hours with a used propane tank and dry stacking cinder blocks around it, and just lining up the heaters on the side of it. It was equally as effective. Next slide, please. So this is just showing the inside of that unit, the propane tank, where the connection from the truck introduced the liquid CO2 into the propane tank. The gas that came off then flows through the stainless steel tube at the bottom to warm it up, heat the gas up to closer to ambient temperature, and then any dry ice that was formed in that process was then the heat from the heaters would melt that or sublimate that dry ice, and then it would be come out with the rest of the gas onto the chamber. Next slide, please. In the background is you can see the ag bag laying there. Next slide, please. And here again, in practice, so we were coming from off of using that heater to collect the dry ice, sublimate it, and heat the gas, introducing it into the ag bag for short-term storage, and then pulling from there to our chamber, so that by having that bag for storage, your system can operate. You can be producing the CO2 gas as you're prepping the trucks, and then just pull out of the bag, so that bag just gives you your temporary storage accumulation while so you don't have to shut the system down between loads. Next slide, please. Here again, just another slide. The critical piece here is probably the flow regulation. So getting from the low pressure storage bag into your chamber, you still got to meet that 5-minute volume exchange. And so here you can either use a blower, if you have a blower with a known that's matched to your volumetric exchange rate, or a valve and a flow meter. Next slide, please. It's really easy to construct a venturi using standard PVC pipe fittings. This is a piece of 4-inch pipe and a couple of and 6-inch pipe. And so by knowing the pressure drop across those two sections of pipe, you know what the flow rate is through that pipe section, and then you, with a valve to control that, you can set it to match the flow rate going into your chamber. And like I say, I've got instructions on how to figure all that up and do that in the references. Next slide, please. Okay, so I really think CO2 is a viable option. We were able to meet the AVMA recommendations for dump truck size chambers, as well as an 80-foot pit using the storage bag to accumulate the CO2. Most of the supplies can be purchased locally. Minimum number of people involved. It's relatively safe. Keep in mind you are working with high pressure cylinders and a cryogenic gas, very cold. So you need to be careful. In that picture of the drum, the frost on the side of it, that was, like I say, that drum was at about minus 80 degrees Fahrenheit. If you stick your hand to it, you don't want to be like the little kid in Christmas Story. Your hand flesh will stick to it. So be very careful. Wear gloves and protective eyewear. Next slide. Here's at the URL top of the page. This is at the North Carolina Department of Agriculture website. They've agreed to host this material after we developed it and to make it accessible to folks. But this was a project that was in large part funded by USDA. But there's some tools there that you might find useful for mass population planning, the overall process and the animal movement. It may be a little late in the game for some of these tools at this point, but you may want to take a look at some of those. Next slide, please. On down on that same page, there's some of the calculators, a depopulation calculator that kind of looks at the trade-offs between CO2 and putting energy into trying to sublimate that dry ice. There's also the small group carbon dioxide system. That's the trailer, the first system that I spoke about. That's the paper on how to size those components. And then that assembly guide at the bottom of the page is for the larger scale system with the heaters and how to size that with an example for to match your flow from your trailer for your chamber and to match the heat requirement to accomplish that. So, next slide. I think that's maybe it. Yeah. So, all right. With that, like I say, if you've got my email, I'm retired from NC State, but I still check my email on a daily basis. So if you have questions, or I could be glad to try and answer those or point you in the direction for assistance.
Thanks very much, Mark. And as we end this webinar here this afternoon, I wanted to land on this slide here for you again. This is Bill Even, your CEO at the Port Checkoff. We've got a couple of items here. Number one, on the left-hand side, it's the pork.org webpage where all this information is going to be placed. Below that is the 1-800 number for our service center. Call that number and you can get directed in. We'll get some messages. If you've got questions, if you need to go where to go get information, we'll be able to help you through that. Or if you want to email, you can email at info@pork.org. On the right-hand side, I want to thank our speakers, Kevin Norton with the NRCS, Mark Rice at North Carolina State, and Lori with USDA APHIS. And a reminder also, this webinar is recorded. The slides are going to be sent to you, so you'll have all the documents, and then we're also going to post these slides on our website. I guess the bottom line, folks, this is not good. We're in a really tough situation here, and the only way we're going to get through it in the coming weeks is to all focus in on the work at hand. As I said to a number of people, it's easy to place blame in this sort of a situation, but the real enemy is the virus. And we want everybody to recognize that the checkoff, you can plug in here to get info, and we can help steer you in the right direction or get you answers. And then our colleagues at the National Pork Producers Council have been very active talking in Washington, D.C. to the USDA, the White House, and others on things related to the policy side of this disaster. So don't be afraid to reach out to us. That's what we're here for. Our job is to serve as this information hub for you in the coming weeks ahead. So with that, that'll end the presentation this afternoon. Thanks for attending, and be sure to share this information widely with others in the industry who may need it. Good afternoon.